All right, I'm going to do a few of these for you, so you're not going into your quiz blind today. I did a few last week, but I'm going to do a few more so we can take a closer look at the equation. Our equation for gravitational force anywhere in the universe is your gravitational force is equal to your universal gravitational constant, m1, m2, over your separation distance squared. Looking at this equation, the more massive the object is, so the larger my m is, the more force I will have. So if I increase my mass, my force is going to increase. So 15 is going to be more. The more massive Earth is, right, my m, again, right, it doesn't matter which m you're talking about. Generally, big M is your planet and small m is your other object, like your satellite or your person or your sphere or whatever. But it'll still be more, right? Whatever mass it is that you're talking about, if you increase one of the masses, your force will also increase. The greater the Earth's radius, so if I increase my radius, my force is going to decrease. These are inversely related. Not proportional, though, because of the separation distance squared. But if I increase my distance, my force will decrease. They're inversely related. So 17, the greater the r, the less force I will have. If two objects originally have a force of 18 newtons, if the separation distance is doubled, then the new force will be. So we just talked about the relationship here. So like I did it last week, when we look at our equation like this, so if I double my distance, so 2 squared over 1, so 1/4. So my force will go down to a quarter of the original. So if it is 18 times a quarter, gives me, I don't know what that is, 4.5. 4.5 newtons. The new force would be 4.5 newtons. So I increase my separation distance, my force is going to go down by a factor of 4. Two objects originally with a force of 18, the separation distance is tripled, so doing the same thing. 1/3 squared would be 1/9, so it's going to be 1/9 the original, which is going to be 2 newtons. Two objects originally have a force of 18. The separation distance is halved, so I'm cutting it in half. What is the new force? So 1/1/2 squared. That would give me 1/4, which would give me 4. So as my separation distance goes down, my gravitational force will go up. And in this case, it's going to be 72 newtons. All right, let's see. If the separation distance of the two objects decreases by a factor of 3, so 1/1/3 squared so 1/1/9, which would end up being 9 times 18. Ooh, you're stretching my mental math. So 162. All right, so that did not take very long to do all these problems. I'm not going to keep going, but it's essentially the same thing. And this one says the universal of Newton's law of universal gravitation is a common source for confusion. The universal means that the force of gravity acts between all objects. It's going to be C. Right, your acceleration is dependent on your location, so is your force dependent on your location. But if you have mass, you have a gravitational force regardless of where you are. Let's see. I know I did one of these, but let's see. Let's do 13. So our G, we'll do it quick. Times 10 to the negative 11. Your mass, 1 times 10 to the 8th. Each, both of their masses. And we have a gravitational force. And we're looking for a separation distance. So we got 4 out of our 5 variables. We always have this one. It's on your equation sheet. Rearranging our equation, we want r by itself, so I'm going to multiply both sides by r. I'm going to divide both sides by your force. Then I'm going to square root both sides since my separation distance is squared in the equation. So plugging in my numbers, 6.67 times 10 to the negative 11 times 1 times 10 to the 8th times 1 times 10 to the 8th divided by 1 times 10 to the negative 3. Combining my terms, so 6.67 times 1 is just 6.67. When you're multiplying with scientific notation, you need to add the exponents. So negative 11 plus 8 is going to be negative 3 plus 8 is going to give me to the 5th power. And then 1 times 10 to the negative 3. When I divide with scientific notation, 6.67 divided by 1 is 6.67, and then I'm going to subtract my exponents. So 5 minus negative 3 gives me 10 to the negative, or to the 8th, sorry. 5 minus negative 3 gives me 8. And then I want to take the square root of this. So I would plug it into my calculator. And for my calculator, I need to do the times 10 to the 8th first, and then square root it. So my separation distance would be 25826 meters. You could put this in scientific notation. If you wanted to. If we're looking at sig figs, we should really just have the one sig fig because that's what or two. We should have 2 sig figs. So this is true, actually. And then if I wanted the proper sig figs here, I would do 26,000. Right, multiplying with sig figs. Anyway, there's some more examples of the work from last week.